Alright, here are some specifics that kind of go along with the video that you just watched with me pulling the yardstick away from the wall. Let's say that we've got a ladder propped against the wall, and the ladder has a length of 10 feet, and that's not going to be changing. And the bottom of the ladder is pulled away at a constant 2 feet per second. Now our question is, how fast is the top of the ladder approaching the floor? And we're going to look at this at two different times. When the bottom of the ladder is 4 feet from the wall, and again when the bottom of the ladder is 5 feet from the wall. Now the first thing you've got to do is organize the information that's given in the problem. In a lot of cases that involves drawing a picture, and the picture will help you organize things. So I'm going to draw the wall and the floor, and we'll make the ladder a different color. And then we want to start labeling this picture with what we know. The length of the ladder is 10 feet. It's always 10 feet. It's not changing, so we can label that with the number. The distance from the bottom of the ladder back to the wall is changing, so we're going to label that with a variable. And the distance from the top of the ladder to the floor is changing, so we're going to label that with a variable. Now, the 2 feet per second is the rate of change of this measurement x. The length of x depends on how much time, how many seconds have elapsed since we started moving the bottom of the ladder. So this 2 feet per second is the rate of change of the measurement x with respect to time t. So it's dx over dt. How fast is the top of the ladder approaching the floor? Well, that's a question about the rate of change of the measurement y. And that's what we want to figure out. So you kind of sort of take some notes on the information that's given to you in the problem. Write down, translate that into some mathematical language. The next thing you got to do is write an equation. And we need an equation that gives us the relationship between the quantities in this picture and the quantities described in our problem. Since we are going to make the assumption that that is a right angle, we're going to assume that the wall is perpendicular to the floor. Then the Pythagorean theorem gives us our equation, x squared plus y squared is equal to 10 squared. And then you need to differentiate with respect to the variable t. Now you'll notice there is not a t in this equation at all, so we have to use implicit differentiation. The derivative of x squared would be 2x, and that gets multiplied by the derivative of x with respect to t. The derivative of y squared is 2y multiplied by the derivative of y with respect to t, and the derivative of the constant is 0. Now we're going to simplify things just a little bit, divide everything by 2. And we're going to start with an x value of 4. We know dx over dt. We're looking for dy over dt. The one thing that we need that we don't have is a measurement for y. So again, using the same relationship, x squared plus y squared is equal to 10 squared, we're going to plug in 4 for x and solve for y. Okay, we're going to take the positive square root only, so square root of 84. So plugging in the numbers that we have, 4 times 2 plus the square root of 84 times dy over dt equals 0. And now we solve that for dy over dt. Negative 8 divided by square root of 84 is perfectly fine. I understand if you want to get a decimal approximation for that, so you have some idea of what number that actually is. And if you round off to 3 decimal places, negative 0.873, the units would be feet per second. Now the question is, how fast does the top of the ladder approach the floor? The fact that this number is negative indicates to me that the value y is decreasing. Which, if you think about that picture and what y is, that means that the top of that ladder is coming closer to the floor. If the derivative value is positive, then the variable is increasing. So it's not surprising that we get a negative here. We need to make sure we answer the question. The top of the ladder moves down at 0.873 feet per second when x is 4 feet. Now, I left out the negative when I answered the question, but I used the word down, indicating the direction. Now, the second part of that question is, let's find dy over dt when x is 5 feet. So, going with the same equation, and I'll leave out some steps because we've already done them. Now thinking 5 squared plus y squared equals 10 squared to get a value for y, and that'll end up being a square root of 75. So 5 times 2 plus square root of 75 times dy over dt equals 0. Solving for dy over dt then will be negative 10 divided by the square root of 75, which converted to a decimal would be negative 1.155 feet per second. So the top of the ladder moves down 1.155 feet per second when x is 5 feet. Now, comparing these two numbers, we have a speed of 1.155 feet per second when x is 5 feet away from the wall, and we have a speed of 0.873 feet per second when the base of the ladder is 4 feet from the wall. So there's evidence right there that the top of the ladder is speeding up as it moves down the wall.